Hello and welcome to another video of GCP GenAI video tutorials. In this video, we're going to talk about introduction of LangChain and GCP PaLM, using LangChain on GCP PaLM models, getting started with code examples and use cases using LangChain with code examples. All right. So this is what you're going to learn in this video. This video is going to be a little longer, so feel free to run it at 1.5x or 1.75x speed. So with that said, let's get started. So what is LangChain? LangChain is a framework for developing applications powered by large language models. Now, large language models can be complicated to build. Therefore, LangChain brings in that framework to help you build GenAI applications. It is imperative that to enable a complete LLM-driven solution, these large language models, LLMs, need to interact with external systems. This makes models data aware, like if it connects to databases like BigQuery, Google Search, with different webhooks, APIs, Google Drive, the external systems could use these connections, repositories, databases, in order to create an application that provides an action or some pieces of interacting with other applications, creating outputs from multiple models, and even chaining the models. It may look complicated to bring all of this together and orchestrate them. And this is where the LangChain can help. LangChain provides you reusable components like integrations and agents, and we will see all of them in a few seconds. Next, please recall, and this is just a quick recall slide, that these are the models that are available in Model Garden, all of these and more. And look at the previous video to understand Model Garden on GCP. Only these three models are supported in LangChain as of now. And the space is changing super fast. So text-bison @001, we are going to see example of this. Chat-bison, we are also look at an example of this. And text embedding gecko, which is for converting text to numerical vectors. You would need to do this in order to do use cases. And let's talk about quickly the use cases that you're going to see. That how do you read a PDF and ask Q&A out of it? How do you create summarization task of a website? How do you search on a website and things like that? So this is what we are going to do in the session or in the examples today. I have multiple use cases for you to look at in today's video. And finally, let's look at the entire thing. You need to remember 6 different components. Chains. Chains let you combine modular components like sequential chain that we're going to see today as an use case, summarization chain, Q&A chain, and other chains. Then you have agents, are very powerful construct that helps you to communicate external systems like PDFs, like web data, like different toolkits that agents provide. Then you have memory. Memory is a very important thing because it's very interesting to note that the conversion from text to numeric takes a lot of time and a lot of memory because each word, each context, each sentence, tokens that what we called as are converted into vectors. And therefore, you would need to save that in a store that is called as vector store. So you can have a conversation memory because that is the buffer, the conversation that you're having with the chatbot. But then you have a vector store where you can store the text to a location. We will see how you could do that. And on the right hand, so these are the inputs, right? These are how you connect to systems. And then you have on the right side LLMs, the text bisons, the chat bisons, embeddings, the text embedding gecko, templates. We're going to talk about prompt templates too. We're going to talk about templates that you would create, how you could chain prompts and things like that. And finally, indexes. So LangChain as a whole, hopefully with the examples that you're going to see in the video today, it's going to make a lot of difference. Let's quickly get started and get on to the LangChain bandwagon. There are a few things that I'm going to assume that you have seen in the previous videos, and I'm going to quickly take a skip. So please install these libraries that include the upgrade of Google Cloud Platform, LangChain, ChromaDB. This is the vector store that we're going to use in one of the use cases, Pydantic, and things like that. Now, first of all, you need to authenticate users. The Colab, I'm using Colab. This is what you're going to do. I have the link 3A, NJ, LangChain, and GCP PaLM introduction. This notebook is available in the GitHub link that is given in the description section below. You would go to File and say Save a copy in Drive so that you make a copy in your Colab. Next, you're going to run this. This authenticates this user ID on the project, the GCP project that you have. Here on the right, or even here, just name the project that you are using. And I'm selecting a location US Central 1. You could select any other location that you would like. And this is exactly the same that we have done in the previous set of videos. Now, let's import few models or few packages. So import time, import typing. LangChain, import LangChain. You have already installed. Please note that after you have installed everything, go to runtime and click on restart runtime. Please note that it is important to restart the runtime for all the packages to take effect, specifically the Google Cloud Platform. You're going to get an error if you do not restart the system. So here, I'm going to get the type LangChain, and then you would print the LangChain version, which is 0.029. Vertex AI SDK version should be 1.28. And then from a Vertex AI perspective, you're getting the AI platform. From LangChain, you're going to get Chat Vertex AI. This is where the LangChain uses Vertex AI embeddings, Vertex AI. So LangChain has chat models, embeddings, and LLM. Remember this slide, LLMs, chat, and embedding. These are the three models that are available. And then these are schemas. Ignore that for now. We'll look at it later. Now, please understand that when you are using Google Cloud, there are some restrictions or there are some quotas that you can hit for embedding specifically. Therefore, this is the utility. There have been a lot of requests, comments, emails from you or my viewers of the channel to find out how you could avoid the quota exceeds error on embeddings API. This is one of the programs or utilities that I would ask you to use. Use it everywhere, wherever you are using embeddings. Next, we are going to call all the three models and initiate it. So first of all, LLMs for Vertex AI. So if I use LLM going forward, now you know that I'm using Vertex AI text-bison 001 model. Recall that text-bison 1001 model was used for PaLM2 for text. Chat model, and then embeddings. This is QPM. This is going to make the process slow because you are using 15 query per minute and you're using number of batches too. But this avoids any quota exceeds error, and I have seen that this works well. The only problem is when you're creating embeddings, please note that it's going to take a little bit of time. But so going forward, if I use embeddings, That means I'm using the Vertex AI embedding, the chat, and the LLM. Run it. Next, now let's look at the three primitive models: LLMs, chat, and text embeddings. Now, LLM, remember, this is the Vertex AI text-bison. I'm going to ask which is the parent company of Lincoln, and I'm going to run it. It say the Lincoln is a brand of Ford Motor Company. Please understand that one of the most important things is because I asked a parent company, it's not answering something related to Abraham Lincoln. It is related to parent company. This is the power of LLMs. It knows that Lincoln is a brand of a car, as well as there was one of the US presidents known as Abraham Lincoln. It knows how to differentiate between two entities which share common names. We will see a lot of this going forward. Chat. Now let's look at the chat. There is something known as human message. Now, let me quickly take you through what it means. When you go to the Google Cloud and go to the generative AI language and look at examples that we have seen in the previous videos, you have context. And this is the message. Message means the input. So the context here, it is very important that you provide the context. It's not given in this example, not needed maybe, but this context keeps the prompt or tells the model that what you're trying to do. So in here, human message is the message that you are typing. For example, content or context in the system message is you are a nice AI bot that helps the user to understand the financial stock market. So what I would do is let's create this over here. So I'm going to create a new code chat or code prompt, sorry, and I'm going to provide a context. Or I can create a text prompt, and in the context of structure, I'm going to provide this. So please understand that you are providing a context, and this system message and human message are the libraries that you imported from LangChain.schema. This is important. The LangChain schema supports human message, system message, and other types of messages. And please note that system message is to more set the context of what you're trying to do, and human message could be a prompt or a combination of prompts. So if I say I like to buy stocks, which stocks should I buy? So it says it depends on your risk appetite. Please note that it also says you may want to consider investing, and then it gives you different. So this is an answer that you got. Now, you can pass more history and have chat history in the response. So look at that. I asked it, by the market cap, what are the top 10 companies? Please note that it is not needed to put system message over and over again. Now, you can also put system message over here, but it's not needed. Even if I run it, it gives me the top 10 companies by market cap. But now it remembers history. Look at that. I said, where is Apple on the list? Which list? Based on what? But it knows that I'm trying to look at companies by market cap history. And therefore, the chat, please understand that the chat model, this model is fine-tuned to do a chat kind of a interface wherein it has short-term memory. That means when you reset application or reset kernel, you are going to lose the history. And therefore, you need vector store. So we're going to talk about that probably after a few minutes. Now, let's talk about text embeddings. Embeddings are ways to represent data, any data, text, images, in terms of numerics. So models, as you know, machine learning models and GenAI LLMs are machine learning models in itself. So all the models are very good with numerics. and therefore it's important for text, images, videos, and other things to be converted into numerics. Embeddings are those. Embeddings is a method to transform your text into a vector. Vectors are also used to compare, to do a semantic search, because now you are playing with numbers, the model is playing with numbers. So let's look at it. Text, Alphabet is the parent company of Google. Now, I'm using embeddings. Please remember, this embeddings is the Vertex AI embeddings. I'm saying text embeddings. First of all, I'm getting the length of the embedding, and this length is not the character length. This is the embedding length. And then I'm looking at the sample embedding. So 768, and then you have these embed. These are the vector representation of this statement, this text. Now let's look at prompts. As you know, that prompts are text used as instructions to your model. For more details, you can look at this notebook. I have provided the link in the description section of the video below. So I'm going to say Meta is the parent company of Twitter. What is wrong with that statement? And I'm using text-bison. I'm using text-bison. LLM is text-bison, not the chat-bison. It says that the statement is false because Meta is the parent company of Facebook, not Twitter. Intelligent, right? Now, let's look at prompt template. Please understand that you would need prompts where user is going to assume something. So for example, if user is talking to a financial AI bot, the user knows it knows finance. If the bot is tuned as a recipe provider for dish or cooking, or if it is a financial planner, if it is a healthcare provider, there are different personas that the bot can take. So prompt template, or for example, template is important to understand and create static versus non-static information to be passed as a prompt. Let's look at example below. So I'm going to create a prompt using prompt template. Now let's look at it. I'm going to create a template. It's just a string. I say, I want to really travel to a location. What should I do there? So what you're going to ask the user is the location. Please note that the location is in the curly braces. And I'm asking, this is instruction tuning, saying that respond in one sentence, short sentence. Here, I'm going to create a prompt template. I'm deciding that there is only one variable, input variable location, which is here. And template, use this template. So you created a prompt, which is an instance of prompt template. Prompt template is nothing but a package or a library from a module from LangChain. And then I say location equals Rome and run it. So it's, you see here, the template is, I really want to travel to Rome. Just ask the location from the users. It's a very simple example, but I'm going to show you a little more complicated example in some time. So you can look at, oops, I'm sorry. It's from a different residue of a different code. So this is what it is. Now you have vector store. Now we are going to talk about vector store. Let's do a quick recap after a long video. So what we have done is understood LangChain, understood GCP PaLM, what models. There are 3 types of basic models. Sorry, I'm just scrolling up a little faster. The text, the chat, and the embedding. Now, we looked at the chat, we looked at the embeddings, we looked at the prompt and prompt template from LangChain. Now let's look at vector store. Vector store, as I mentioned earlier, it's a database, it's an index that can store embeddings, vectors. There are two vector stores that I'm going to talk about. One is Chroma. ChromaDB is an open source vector store, and you have Vertex AI Matching Engine, which is the fully managed vector store on Google Cloud. Developers can use Vertex AI Matching Engine as part of Vertex AI portfolio, and I'm going to quickly show you where is Matching Engine. If you go to Vertex AI, scroll at the very end, you see Matching Engine service. This service can help create indexes. Those indexes are nothing but the vector store, and then you create index endpoints. This is for a different video when you can ask Matching Engine to provide you embeddings. Please understand that as a good design principle, you would like to create a vector store once, and as long as your data or underlying data does not change, you would continue to reuse those vectors or embeddings so that you don't have to pay for multi-embedding scenario. So always create embeddings, store it, and reuse it multiple times, as long as the underlying data remains the same. If the data changes, then obviously you have to retrain embeddings. And that is the difference of managed Vertex AI matching engine. In ChromaDB, you have to retrigger the embeddings generation. However, Vertex AI matching engine would retrigger an index creation using the Vertex AI matching engine if there is more than 20% of data, 20% of the data that is changed underlying. So with that said, we're going to come back to matching engine later. Now, I'm going to show you how you can store embeddings. So I'm going to use this cloud link. You can go here, copy, and see this tab. So I'm going to use this as the source. This is just an explanation page of embeddings and groundings for LLMs. So I'm going to use this page. And then LangChain provides text splitters, document loaders, and vertex stores. All of this I'm going to show you later in a different video in detail. But for now, assume. And by the way, I'm using the Facebook's for this example, my bad. So we are using the Facebook's open source document embedding store. So this is the way how you load the document. Now, once you load the document, you need to split the text. The text needs to be split because there is a limitation on the number of tokens that an LLM can process. I repeat, you would need to split the text because there is a limit on the number of tokens that an LLM can process. And therefore, you would use a text splitter. And again, LangChain. Remember, we are using LangChain. LangChain is providing a text splitter. There are several types of text splitters, but you have recursive character text splitter, which is available. And you can split the document, which is this, into text. So if I run this, it's going to read this. And now you have 10 documents. That means the 10 chunk size 15 over a chunk overlap of 50. There are 10 of those text. And then you can create an embeddings using Vertex AI embedding. So I'm just going to run it. You see here it says waiting, ... It's going to continue running it. It's going to take 25-30 seconds because the data is not big. In the use case that is going to follow, you're going to see that this is going to take 8 minutes, 10 minutes, 15 minutes. And then finally, you have the embeddings. And these are some sample embeddings. Now, with that said, what I'm going to do is the video is getting longer. So I'm going to stop the video here. And then in the next video, we are going to look at the chains as a use case. So simple sequential chains, Q&A, So we are going to look at question answering chain, Q&A chain, and summarization chain. So with that said, please wait for the next video. Thank you for watching.